Hello everyone, my name is Alan and welcome to a new model we're making. It's going to be kind of like an industrial tank like we did last time. However, it's going to be a different shape and it's going to have more details. So I'm going to draw it real quick. I'm going to use Microsoft Paint. It's not the best, but it'll work. So it's going to be a circle over here. It's a spherical shape. It's a spherical model. So then so the circle, so we're gonna add the kind of like equator if this was a globe. And we're gonna add a few columns going around the model to help hold it up. Oops. It's like this. Then we have a platform at the top. And we're gonna have a staircase coming down from this top platform. However, I'm not gonna draw that because that's pretty complicated. So first, let's import our things. So import BPY, but that's what we used last time. Import math and math utils. Okay, I'm gonna do something fancy and right. Basic function. Create the tank. But you don't have to do this unless you want to. Alright. Def create tank. Sphere radius. Okay. So sphere radius is the only parameter we have right now. But it's the only parameter we need. And you'll see why once we get going. So right now I'm just adding my comment. Alright. The top from z value, we'll get into that later. Okay, now tank UV sphere. And I'll get into what that is later. So tank radius is the sphere radius because they're the same thing. Sphere z is equal to tank radius. And what sphere z is, it's just the center of the tank. So you see the z-axis on over here is just up and down. The tank radius is to make sure it's like a in the middle. It's like the core, and the radius is tells the code where the core is. That ppo.ops.mesh primitive UV sphere add radius The radius is just the tank radius. Location is the 0 in the sphere. Segments, and there are segments and rings, and I'll get into what they are. So we're not going to create a smooth sphere. The spherical object is actually going to be made of separate pieces around the ball, and the rings are just there to help the pieces know where to go. So they're kind of like the Tropic of Cancer in Capricorn, if we're sticking with that globe analogy. Next, we have sphere. The BJ is bpy.context.activeObject, and we're going to give it a name. Okay. And why do we need to give it a name twice? Because this just takes the active object, which is this, and gives it a name, but then we also name it again to spherical tank. So this name is the one we're going to use when we're coding Python, but this is the name like over here. The scene collection is going to be the spherical tank. That's going to write the support columns at the equator. So num columns is 6. The height is going to be equal to the tank radius. The radius is going to be the sphere radius times 0.05, and no, columns. The angle is. Alright, now we're going to do a lot of explaining. Okay, first, this part. Okay, so the columns that's going to be supporting the tank, that's like a model of that. So let's say this is kind of like the equator over here, except we flip it and now it looks 2D. And let's mark where the columns are gonna be with triangle. Okay, we're gonna have 6. We're gonna have 6 columns. And now let's make the center of the circle. No. It's too big. The center of the circle, which is still not around. Okay, I'll just. Okay, there's the center, and now we're gonna draw lines from it to all the directions. Not all the directions, I meant to where the columns are. Alright, now that we've drawn this, let's go to the code and see this. 2 times math pi divided by number column. So 2 times math pi is actually the full circle, 360 degrees around. And number of columns, see, it's just, we have 6 columns, and we're just splitting the angles, 360 degrees, into 6 columns, 60. So each of these is around 60 degrees. Okay. The I, so it's every time this for loop runs, it goes to the next column. So here, this is I 1, 2, 3, 4, 5, 6. Okay. Now, how is this code going to find where these columns are going to be, because it doesn't know where to place them yet? Well, over here, let's draw this. Okay, this is a coordinate plane. We have the x and the y coordinates. And, okay, see, this is a right angle over here. Alright. Okay, and then we have a point over here. So what is the x coordinate? Well, it is like the length of this part. If you draw a straight line, not a straight line, like a line, yes, a straight line down where it's like perpendicular towards the x coordinate, so that it forms a right angle over here. So if you draw a line down here that's perpendicular to the x coordinate and it has a right angle over here, then you know the value of the x coordinate. The same thing for the y coordinate, except it's a horizontal line over here, and it's still a right angle, and this value is the y coordinate. And let's do that too, and I'll explain how this helps us find the coordinates of this point here. Okay, so let's say this point is, this point is where our column is going to be. So let's draw that. So let's take this point, for example. And let's say this radius is the x-coordinate. So let's draw the y-coordinate here. Okay, let's extend this. Alright. So these are the coordinates I marked with the arrows. Alright, let's draw the perpendicular right angle line down to this x-coordinate. Alright. And now for the y. Okay, now let's mark theta, which is like the angle. So we have theta and theta over here, which is the angle over here and the angle over there. Now let's just mark some places. So the length from here to here, where the line touches, that's going to be B, and the line from here to here is going to be A. Okay, let's label the x coordinate and the y coordinate. Okay, we have this. Now, how are we going to use this to find this coordinate? Well, we want to divide. Oh wait, let's label this radius. This radius is going to be C. Okay, we want to divide A by C and also B by C. But we can't just do that. That's not how we get it. So I'll just tell you how the formula is. That's like the equation. So cosine theta times C, and that's equals to A. Alright, and here, so cosine theta is equal to A divided by C. So basically we just multiply the C over here. So A equals cosine theta times C. And what this equation is going to give us is that it's going to give us the x coordinate for this point. And you can see cosine theta is A divided by C, but we also multiply the C again. Okay. Which gives us the A. Next, now we do sine theta is equal to BC. So we do B is equal to sine theta times C. That's the y coordinate. So that's the cosine and the sine. So, and that's how I'm going to find the coordinate for these places. So the x coordinate for the column is tank radius times math the cosine angle. We use the math function to use the cosine. Okay, then tank radius times math sine angle. Alright, behavior ops dot mesh dot primitive cylinder add radius is equal to column radius, depth is column depth, height, and location. This is why I use the math from earlier. Column height divided by 2. Why is the column height divided by 2? Well, because you see the z is in the, when we define the z coordinate, we want it to be in the middle of where the model is. So we take the height divided by 2 to get the middle. Alright. And this should end this. Okay, OJ is equal to. Now we just give it the name active object. We use that active object was use the active object with the column, and just give it a name. This name is a bit different though, because we have multiple of them. So we just use the F string to get the name for Blender. Okay, next we make the platform at the top, and if we're gonna use the globe, it's gonna be at the North Pole. So I'm gonna write top platform at North Pole. The thickness is sphere radius times 0.05 times 0.05. Platform thickness is sphere radius times 0.05. Platform radius is just half of a sphere radius. Then top platform z is equal to 2 times tank radius plus platform thickness, but half of that. So platform thickness is just 0.05 of the sphere radius. Platform radius, this is half of the sphere radius. However, top platform z is the height. So it's double the tank radius, because if you go over here, the tank radius is like this, okay, which is kind of like this on this model. And a better way to draw it in this context is this. This is the radius. So if you want to do it twice, you're going to move it up here. And this is where the platform is. However, remember the z has to be the middle of the platform. And this is at the bottom. So we just got to add the half the platform thickness to it, so that it can come in the middle, because half of the platform thickness is the middle of the platform. Alright. Next, we're just going to add the cylinder, and we already defined the parameters up here, so the radius is just going to be platform radius. We already know everything. The depth is the platform thickness. And the location is 0.0, top platform z. Okay, top platform j bpy dot context dot active object top platform obj dot name is top platform. Yeah, so we're just naming it again, and we're going to return top platform z. Alright, we're gonna add the floor next. So let's go here, and I gotta make it look fancy again. New function. Add floor. Alright. Now let's have the define function here. Sphere radius. And then another comment. Add a large floor plane with given floor material. Floor size is, oops, there you go. Floor size is equal to sphere radius times 10. It has to be really big so I can cover the floor. The size is just going to be the floor size. The object is going to be the floor. And I wrote the wrong, converted the wrong time. Location is 0.0. Okay, so it's just going to be 0, 0, 0, because it's going to be so big, it's going to be everywhere. Okay, now let's just name it. Okay. Now our last function for this lesson is going to be a setup scene like we did last time. So we're just gonna run everything. We're just gonna set up everything. We're not gonna run it. And then we're gonna run everything after this line. Okay. Okay. Sphere radius is also the parameter. Okay. It says handrail here. It's preparing for future lessons. So we're gonna write that for now. Same thing for the spiral staircase and the realistic materials. You're gonna add them in later lessons. Okay, select all. Action is select qi.obs.object.delete use global false. So yeah, we're just clearing everything so we can put our new model in, because if we don't clear anything, then then yeah, there's gonna be too many objects over here, and that's not going to be good. Okay. Okay, create tank using top platform Z, and then we'll have to add a bit more stuff, and then we can run it. Add floor, sphere radius, add realistic materials. However, it's going to be an error if you don't comment this out, because we don't have this yet. But we're going to uncomment it out in future lessons. Now we have, actually, let's run the code. Setup scene sphere radius is 2.1. Okay, now it's going to yell at me because of some typos. Yeah, typos, like I didn't add commas, so make sure you don't have any typos. Here, okay. Here. Okay, ring count. Column x, column height divided by 2. Oh, here. I didn't write that. Okay. Now everything's running well. And here is our model so far. You can see it's pretty good. We have the six columns here, all equally spaced out. And you can see kind of like the equator we talked about over here. And the circles, like if we're still using the globe, it's like Tropic of Cancer, Capricorn, Arctic Circle. And we also have the platform at the top. So next lesson we're going to add the staircase. So you're going to add materials so it looks realistic. So I'll see you then. Bye.